video for AQA Further Pure Mathematics, Algebra and Graphs section 2.1, which looks at inequalities of the form f of x is less than 0. Well, by an inequality we mean relationships involving greater than, less than, greater than or equal to, or less than or equal to. Two types of inequalities. Those that are only true for certain values. So as an example of that, something like x squared is greater than 9, so x is greater than 3 or x is less than negative 3. And those are certain values for which the inequality is true. Or the second type, those which are always true. For example, x squared plus y squared is greater than 0 for all values of x and y. Well, given an inequality, we can manipulate them, and I'm sure you know how to do this already. Certainly if x is greater than y, then we can add a number to x or to y, and then the inequality will remain the same. So if we add the same value to to x or to y, then the inequality is still true, and a can be positive or negative. We can multiply by p as long as p is positive, then the inequality stays the same. It will change round, however, if n is a number which is less than 0, then the inequality changes direction. So here we've got x is greater than y, then means that nx is less than ny, and that's for a value of n which is less than 0. So this is the idea: if we multiply by a positive number, then the inequality is fine. If we multiply or divide, for that matter, by a negative number, then the inequality changes direction. And then we have this rule that says that if a is greater than b and x is greater than y, if we add those two together, a plus x must be greater than b plus y. And then finally, if we have an inequality that says x is greater than y and y is greater than z, then x must be greater than z. So those are rules that you can apply to manipulating inequalities. I now want to look at how we can solve inequalities of the form f of x is greater than 0. There are two main methods of doing this. The first one is to plot a graph. So we know how to sketch graphs, plot graphs, and then seeing if we can tell from that where the graph is above the x-axis, or if we're looking at less than 0 below the x-axis. In other words, where it's positive or negative. And the alternative of that is by solving the equation using an algebraic method. So let's consider this graph, or this method, for 1 over x minus 1 over x plus 2. This is a graph that we've drawn before, and so the result of that, remember, it's going to have asymptotes at 1 and at negative 2, and it then had a maximum value somewhere which was a negative value between negative 2 and 1. So that graph we've drawn, and therefore we can say if we want that greater than 0, then it's greater than 0 to the left of negative 2 and to the right of 1. So for values of x which are less than negative 2 and greater than plus 1. Now, an algebraic method can be used particularly where a graph is going to be difficult to draw, or we don't actually need to bother drawing a graph. So if it's one that where we're just asked to solve an inequality without first sketching a graph, then sometimes algebraic methods are going to be quicker. the thing to realise is that the sign of the function only changes where it passes through f of x equal to 0 or where it's undefined, so either side of an asymptote. So these values where f of x equals 0 and the asymptotes, the vertical asymptotes, these are what are called the critical values. And at critical values, the sign of a function can change from positive to negative or vice versa. So once we've identified the critical values, we can then use the factors in the function f of x to decide whether f of x itself is positive or negative, or perhaps even equal to 0. So an example of that coming up now. So this is our example. F of x is x minus 3 over x minus 1, x plus 2. So the critical values are at x equal to 3, where we can see that f of x must be equal to 0, because the top line is equal to 0, and then x is equal to 1, and x is equal to negative 2, and these are asymptotes. So once we've got the critical values, we can look at the regions to either side of those values. So starting off with the region below x is minus 2, and then between negative 2 and 1, then it can change there, the next asymptote, between 1 and 3, and then we should look at x equal to 3, because that's the one where it's equal to 0, and x is greater than 3. So the critical values, which were at negative 2, at 1 and 3, produce the regions. Notice there that I've included there x equal to 3 because I want also to look at when it's equal to 0, the function. Now the factors in f of x, x minus 3, x minus 1 and x plus 2, we can decide whether they are positive or negative. So taking first of all below negative 2, then all of these must be negative, and that means that f of x itself is negative. If we go though to between negative 2 and 1, then x plus 2 becomes positive, although x minus 3 and x minus 1 are going to be negative. So you can see there that the function has changed sign to being positive. We've got two negative factors and one positive one, and therefore the function itself is positive. Between 1 and 3, then x minus 1 has become positive, as well as x plus 2, but x minus 3 is still negative, so the function itself is negative. Then at x equal to 3, we know that we've got 0 here, and these are both positive, so the function is 0. And then for x greater than 3, we know that all of the factors are positive, and therefore the function itself is positive. Now we're asked to find the values of x for which f of x is greater than or equal to 0. We can see that it's greater than or equal to 0 between negative 2 and plus 1, and also from 3, including 3 itself, upwards. So we would say that we've got x is greater than negative 2 is less than 1, or x is greater than or equal to 3. That's the end of this video on inequalities of the form f of x equal to, greater than 0. And in the next video we'll be looking at inequalities of the form f of x is less than g of x. So we've got two functions, one on the left hand side and one on the right hand side of the inequality.